this example, we're asked to solve the rational equation. We've got 2 over x equals 3 minus 8 over x plus 4. The very first step in solving a rational equation is to make sure that all denominators are completely factored. And we just have 2 denominators here, the x and the x plus 4. Neither one of these denominators can be factored, so that step can be skipped. We've made sure that all denominators are completely factored. The next thing to do is to write down any restrictions on the variable. So I want to make a note to myself here that what is x not allowed to equal? In other words, what value of x would make this denominator 0? And that would be 0 itself. If we substituted 0 for x, this denominator would be 0, which would make this fraction undefined. So x can't be 0. And then from this other denominator, negative 4 plus 4 would be 0, so x can't equal negative 4 here. So x can't equal 0, and x can't equal negative 4. We've got 2 restricted values. If, once we're done solving this equation, we get either 0 or negative 4, then we'll conclude that that value is not a solution. Okay, next thing to do is to multiply both sides of the equation by the least common denominator. And in this problem here, the least common denominator would have to involve x and x plus 4. Those are the 2 denominator factors. So let's multiply both sides of this equation here by x times x plus 4. Okay, I showed that I'm multiplying the left side by x times x plus 4. And I'm going to show that I'm multiplying the right side by x times x plus 4. So on the left side, there's no distributing that needs to take place. We can just start simplifying. So the x's can be canceled. And we end up with just 2 times x plus 4, which is the same thing as 2x plus 8, if you prefer to write that at this stage. On the right side, we've got to distribute the x times x plus 4 to the 3 and to the 8 over x plus 4 term. So it's going to be 3 times x times x plus 4, and there's really no need to write the times dot there, so I'm just going to write 3x x plus 4, and then minus 8 over x plus 4 times x plus 4. On the left side, the 2 needs to get distributed through the parentheses. That becomes 2x plus 8. And on the right side, we've got to distribute the 3x through the parentheses to clear the parentheses here. That's going to be 3x squared plus 12x. And then for this last term, 8 over x plus 4 times x plus 4, the x plus 4 factors cancel each other out, and it simplifies to just 8x. So we have minus 8x. So notice at this stage, all of the fractions have been cleared, which means we're on the right track, we're doing it properly. Let's think here. We've got a quadratic equation. There's an x squared term, which means we're going to need to get it set equal to 0 with all terms on one side. The x squared term is currently on the right, so we want to bring all terms to the right side with a 0 on the left side. Before I do that, I'm going to combine like terms on the right. We've got a 12x and a negative 8x, which combines to positive 4x. So I'm going to rewrite the right side by combining the like x terms as 3x squared plus 4x. Let's get everything to the right side by subtracting 2x from both sides, and then also by subtracting 8 from both sides. So we've got 0 on the left, and on the right side we've got 3x squared, 4x, and a negative 2x adds up to a positive 2x, and then a negative 8 or a minus 8. So we've got a trinomial here, set equal to 0. The trinomial hopefully can factor, and then once we factor it, we'll set each factor equal to 0. So I'm going to break open 2 sets of parentheses to prepare to factor our trinomial. I'm thinking what times what is 3x squared, and that would have to be 3x times x. Now I'm thinking what times what is 8. So that could be 4 times 2 or 8 times 1. The goal is to get a positive 2x for the middle term, so we're just going to have to try something and see if it works. I'm going to try a 4 and a 2 first of all. I'm thinking of a 6x and a 4x. We can make those 2 terms add up to a positive 2x if we make it a positive 6x and then a negative 4x. So I believe this works. 3x minus 4 times x plus 2. We do get a negative 8 from multiplying negative 4 times positive 2. Then we need to set each factor equal to 0 to finish solving for x. So it's 3x minus 4 equals 0, or x plus 2 equals 0. If we add 4 to both sides, this first equation here is 3x is equal to 4. And then if we divide both sides by 3, it's x equals 4/3, or 1 1/3 if you prefer. And then the other equation here, if we subtract 2 from both sides, it's giving us x equals -2. We've got two potential solutions, 4/3 or -2. We need to check and make sure these are valid by comparing them to the restricted value that we wrote down initially, or the restricted values. X was not allowed to equal 0. We didn't get that. And also x was not allowed to equal -4. We didn't get that either. So these answers are both valid. We have two solutions to this equation, and in solution set notation, we could write the answer like this. In set braces, -2, 4/3.